Here is a rectangle intersecting with y is equal to negative x squared plus 6x plus k quadratic function. Solve for the maximum value of the perimeter of the rectangle ABCD. If you think about what the maximum value in our quadratic function will look like, we can obviously think about the two types in our quadratic function. And the two types we're going to define by our leading coefficient, which we usually notated as a. So the first case in our quadratic function will be the case with our a value, our leading coefficient is greater than 0, which means when our leading coefficient is positive value, the graph of a quadratic function will open or go upward. When the quadratic function's graph opens upward, for example, it will look something like this that keeps going toward upward and never intersects at a specific one point. But then it will contain one specific point, which is another most important subject or the thing in our quadratic function, which we usually notated as the minimum or the lowest point on our graph. So this will gonna occur when our a value is greater than 0. So if you think about the second case in our quadratic function, it will going to be the opposite of our first case, which means our leading coefficient a is less than 0, which means when it is negative value, the graph of a quadratic function will open or it will go downward, unlike the first case. When a quadratic function's graph opens downward, for example, it will look something like this that keeps going toward upward and downward, and we're going to contain one specific point, which we call it as the maximum point or the highest point on our graph. So we can think about the definition of a vertex. In this case, there are two types of graph, and the vertex will going to be the addition of the number of possibilities between the minimum point and the maximum point. Our quadratic function will going to be y is equal to negative x squared plus 6x plus k. And if you thinking about the maximum point on our graph, we need to convert our quadratic functions into our vertex form or some specific form in order to solve for it. But then if there's any variable, which in this case will going to be k, so k will going to be unknown variable that we need to solve for it in order to complete our quadratic function form. So in order to solve for a variable in our quadratic function, we need to use our input and the output theory, which means if we input some specific value, we're going to give us the output of a quadratic function with a variable in it. And then all we have to do is we need to isolate our one term and just a integers into some kind of spaces in order to solve for our output, which will going to be variable in this case. So first of all, let's think about the given coordinates. So first of all, the quadratic function is intersecting with two kind of stuff, which we usually call it as the x-intercept. And if you think about what the x-intercepts will going to be, the definition of the x-intercept will going to be when we convert this into a quadratic functions or the coordinate, it will going to be x comma 0. Which means when our x-intercepts definition will going to be when our x value, our input of our function is equal to something, and we notate it as x because it is a variable, which means it changes all the time. And for our output of our specific function, we're going to be 0. And our output in this case, we're going to be y. So first of all, if you think about the x-intercepts, all you have to do is we can simply input our x value as 0. So if you think about it through our equation, since we have lots of variables inside our quadratic function and there is no information, we can figure out that our x-intercepts were going to be 1, 7, which means when you convert this into our coordinate, it will going to be -1, 0, and the second one will going to be 7, 0. So these terms will going to be our two x-intercepts. We need to convert this into some specific form of our quadratic function in order to solve for our basic format. And in order to solve for it, this will going to be our x-intercepts, and the form that is optimized when it comes to solving for the x-intercepts will going to be a binomial form. The reason is because binomial form will going to be same thing with the standard form, except it is formed by a x-intercepts. So if you think about the basic format of a binomial form, it will going to be a times x minus something. We can call it as z times x minus y. And this y will obviously not going to be our output, since we knew that z and the y will just going to be some integers. And if you think about what the a will going to be, the a will going to be exactly the same thing as we did here, which defines our two types of graphs as well as the types of our vertex in our quadratic function. So first of all, z and the y value should always be a positive value in order to make this into equal to 0. The reason is because our output of our function should always be equal to 0. That makes our x-intercepts. So first of all, we could write a times x, and then 2 x-intercepts, it should be 1, but then it should be negative 1, so we can write it as positive 1, and then it will going to be x minus 7, and that will going to be equal to 0. And still, we could say that a will going to be our leading coefficient, which means it will going to be a coefficient of the highest degree power term, and our highest degree power term in the quadratic function will going to be x squared. So our leading coefficient of our x squared term will going to be negative 1. So we can fill our formation. It will going to be negative times x plus 1 times x minus 7, and that is equal to 0. All you have to know is we need to convert this into a standard form. The reason is because our original function is formed by the standard form. And if you think about the basic format of our standard form, it will going to be y, where f of x is equal to ax squared plus bx plus c. And that is exactly the same thing with simplifying our binomial form into extensions. So if we simplify our binomial form, will going to be negative x squared minus 7x plus 1x. But it can't be negative 7x because we have our negative. And so it will going to be negative times x squared minus 7x plus 1x, and then minus 7. And then if we even extend it further, this whole thing will turn into negative x squared, and then plus 6x plus 7. And all we did was we distribute our negative value into all of our terms. And so our k value was our y-intercepts in our standard form, which is also a constant according to the property of our standard form. So our constant in this case will going to be 7, and we could figure out that our k value will going to be 7. So our full function will going to be y is equal to negative x squared plus 6x plus 7. Let's think about what our c value will going to be. And our c value point is right over here, where it is also relying on the x-intercepts, but we don't really exactly know what the c value will going to be, so we can set it as the c comma 0. Now let's think about what our symmetrical line will going to be. Our symmetrical line is same thing with is same thing with the average of x-intercepts, which means it is a line that divides this whole quadratic function into exact half. So for our so we could usually use it through our binomial form, and our binomial form was negative and then x plus 1 times x minus 7. And from here, our x-intercept was -1 and then positive 7. And our average is same thing with the mean or arithmetic mean, which we're going to be -1 plus 7. And then divide by 2, which we're going to be 6. Divide by 3, divide by 2, which we're going to be 3. So 3 we're going to be our average of our x-intercepts, which means this will going to be a symmetrical line. So from here we can know one thing, that we could solve for the B point coordinate. And our point B coordinate is also relying on our x-intercepts. And our coordinate of the B, from here we can use our C point and our symmetrical line, which will going to be 6 minus C, comma 0. The reason why it's 0 is because this is relying on the x-intercepts. So this will going to be point B's coordinate 6 minus C, comma 0, and our input of our function, which will going to be our x value, will going to be 6 minus 6. Therefore, the segment BC, will going to be 2c minus 6. And all we used is our CB point as well as our average of x-intercept, which we're going to be symmetrical line. So this will going to be our segment BC's length. And from here, we need to solve for our point D. And our point D is right over here, which is exactly same thing with its y coordinate. So the these y-intercept is exactly same thing with the x. The coordinate of the x will going to be c. So in order to solve for our output of our function, which will going to be d, all we have to do is we need to input our c as our x value to our original function. And our original function was y is equal to negative x squared plus 6x plus 7. And if you input c to this function as our x value, we're going to be negative c plus 6c plus 7. All we go in this question will going to be the perimeter of our rectangle ABCD. In order to solve for a perimeter, it is, if you think about the formula for it, it will going to be length times 2 plus our width times 2. So our lengths will going to be from the BC, which will going to be 2c minus 6. And we can multiply by 2. And we have plus w times 2, which will going to be our width. And our width of our rectangle. We're just squared here. And if you think about simplifying things, we're going to get 4c minus 12, and then plus negative 2c squared plus 6c times 2 will going to be 12c plus 14. So we can also simplify from here. For c plus 12c, we're going to be 16c. And we have negative 2c squared. And then we still have plus 2. And we still have our negative since the in front of c has negative. And so in order to solve for our maximum value, we need to convert this into a vertex form, which is optimized when it comes to solving for our vertex of our function. If you think about it, convert the standard form to a vertex form is the same thing with the completing the square. It is the same thing with the completing the square, which means same thing with the converting the standard form into a perfect square form. First of all, we need to divide whole term by stuff in order to make our leading coefficient equal to 1 for our convenience of our calculation. We're going to be negative c, but then we divide negative 2, we're going to have positive ac, negative 1. And then we can divide negative 2 times c squared plus ac. Then divide by 2 times square, which we're going to be positive 16. But we need to get our negative 1, which we will going to be our original constant. But then if you multiply negative 2 plus 16, we're going to give us negative 32, which means in order to be our negative 1, we need to add 31 back. And from here, we can finish our converting stuff, which we're going to be negative 2 times c plus 4 squared plus 31. So our maximum point in our quadratic function will going to be when our c value is negative 4. Our y value, which will going to be our output of our function, will going to be 31. So for our total answer in this question, we're going to be when c is equal to negative 4. Our output of our function, which is essentially going to be the perimeter of our rectangle, is going to be 31.